Alright, let's talk about exponent rules and try to get a feel as to why these things even work out. So if I have x squared times x to the third, what does that really mean? Well, x squared means x times x, and x to the third means x times x times x. So when I multiply these things together, what do I have? I have x times x times x times x times x, which is equal to x to the fifth, which is also equal to x to the 2 plus 3. So when I have an exponent on an x times something else with an exponent on x, I can add those things together. And this is why. Now, the rule of division, if I have x to the 7th over x to the 5th, what do I have? X times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. All over x times x times x times x times x. Now, as we know, when we have something on the top and something on the bottom, those things are the same, we can cancel them. So I've got 5 x's down here, means I can cancel 5 up here. 1, 2, 3, 4, 5. Now what am I left with? These two, which is equal to x squared, or equal to x to the 7 minus 5. So if I have x to the m over x to the n, I can say that's always equal to x to the m minus n. Now this has another consequence, and something you might have seen before. Let's reverse it. Let's say I have x to the 5th over x to the 7th. Well, we know that's x times x times x times x times x over x times x times x times x times x times x times x. Now I'll do the same thing I did before. I just cancel what's the same on the top and the same on the bottom. So those 5 go away and these 5 go away. And I'm left over with 1 over x times x, or 1 over x squared. Now when I use the rule from the previous step that x to the m over x to the n is equal to x to the m minus n, if I use these rules on this guy, I'm going to have x to the 5 minus 7 equals x to the negative 2, which is equal to 1 over x squared. So this negative in an exponent has nothing to do with this base being negative. All that means is that it exists in the denominator. I like to think of it as this x is sad in his place in this fraction, right? So to get him happy again, we're going to put him in the opposite place. So if I have something like 1 over x to the negative 6, he's feeling negative in the denominator, so I will get him feeling positive and put him in the numerator. So that's how that rule works. And there's one final one, which is x to the m raised to the n is equal to, well, let's go find out. So if I have x squared raised to the 3rd power, what does that mean? That means x times x raised to the 3rd power, which means x times x times x times x times x times x, which is equal to x to the 1, 2, 3, 4, 5, 6, x to the 6, which is also equal to x to the 2 times 3. So when I have x to the m raised to the n, I have x to the m times n. And that concludes our exponent rules. I hope that they're a little bit more intuitive after watching this, and not too much going on here, just canceling x's and adding groups of them.